All right, so we're looking at section 4.2 again today. So we're working with those systems of three equations, and we're going to take it a little bit further today because we're going to recognize inconsistent and dependent systems. So we're going to kind of apply that same stuff that we did with a system of two equations with our system of three equations here. So a little bit of warm-up. We're going to do graphing for the ones on the left, and then we're going to solve with substitution and elimination for the one on the right. We're going to do it with both, okay? So pause the video and work through those. You can work through them on your notes. If you want to do it on the table, you can do that as well, but I would recommend working through them on your notes so that way you have them to look back at. One on the left here, we need to make sure that everything is in mx plus b form here. So we got to take this one right here and rearrange it. So the only thing you have to do is move the x over, okay? So we have y equals negative x minus 1. So we're graphing this equation and this equation on the same graph. Okay, so just draw a graph here. Let's do this top one. So starting at negative 1, we go down 1, right 1, down 1, right 1. And we're going to go up 1, back 1, up 1, back 1. Just to kind of keep our pattern going the other way as well. It's a little bit harder since I didn't give myself a graph. And then our second one, I'll do that in red. So we're going to start at 2. So right there, we're going to go down 1, right 2, down 1, right 2. And it doesn't look like we're going to hit going that direction, so let's go back the other direction. I'll give myself a few more marks here. So up 1, left 2, up 1, left 2. And I need to continue my other line. Okay, so we were here, up 1, back 1, up 1, back 1, up 1, back 1, up 1, back 1. And we're going to hit right about in here. I didn't give myself the best lines to go with here. All right, so what I'm going to do here, just so in case we run into this in the future, in case you run into this, I'm going to show you how to double check your graphing algebraically. Okay, so we're going to take this one and we got to rearrange it to standard form. So that means we got to move this over to the left, which makes it a positive 1/2 x. And then we're going to multiply everything by 2 to get rid of the fractions. Okay, so we'll have x, and we'll multiply this by a negative 2. That way it's going to fix it right away. Or we're going to cancel it out right away. So negative x minus 2y equals negative 4. And we multiplied everything by a half. That way we can kind of get rid of the fractions. And now we can add these two together. So we'll get a negative y equals negative 5, so y equals 5. And we'll see if we did that right. So we should have 5 for the y. Plug that into this one. Okay? So x plus 5 equals negative 1. So that means we're going to get x equals negative 6. So I should have a point at negative 6, 5. Okay, which I was a little off with my graph here. Okay, but if you did that on graph paper, it would look a little bit better. So negative 6, 5 is your coordinate. Okay, so if you're asked to do this graphically, you can also double check it like this, just if you want to be sure. If you're feeling more comfortable with your substitution or elimination stuff. Okay, so off the right here, we're going to do elimination first, and then I'll show you substitution. So these are already opposites. The y's are already opposites, so we don't have to do anything here except for just add them. So let's add these two equations together. So 3x, y's go away. We get 15 on the right. Divide by 3. We get x equals 5. Okay. Once we get an x, go back up here. Doesn't matter which one we want to plug into, whichever one is easier. I'd probably say this one since there's no number in front of the x. 5 minus 3y equals 6, and solve that. Okay? Move the 5 to the right, and we get negative 3y equals 1, y equals negative 1/3. Okay, so it looks like we're working with a fraction here. So let's take this and plug it back into this equation here for y and see what we get. So if I'm putting a negative 1/3 in here, that's going to cancel with that 3, so that would make it x plus 1 equals 6. Move the 1 over, x equals 5. Okay, so we get 5 comma negative 1/3. And just because I got a fraction here, I want to double check it to see if it works in the other equation. So we're going to take the x and the y that we got here and plug it into this equation. So 2 times 5 plus 3 times negative 1/3. And we'll see if this gets us a 9. So this is a 10. I'll write that here. This is a negative 1. So that does, in fact, work. So that is correct. All right? And I wanted to double check it because I saw fractions. And a lot of the times when you're working in math classes, if you get fractions with these, it may or may not be right. So you might want to double check it. Okay? So hopefully that's plenty of review. That's the 3 basic concepts from systems of 2 equations. All right? Now we're on to systems of 3 equations. So you could have different types of solutions for these. We can have where there's exactly one solution. That'd be where it simply works out. Let's say you got like negative 1, 3, 5. That would be your one solution. Okay? You could have infinitely many solutions. So think back to systems of 2 equations when you ended up with something like this. And you're like, does that make sense? Or maybe like you could have something like that where 3 equals 3. Does it make sense? Yes, it does. If you end up where everything cancels out and you have a number equal to number, then that would be infinite solutions, all real numbers. Okay, and then the third scenario is where there's no solution. Okay, so looking at these diagrams, there is no place where all 3 planes intersect at once. Okay, this right here on the right would be the most obvious one that your brain might come up with, just 3 parallel planes. But if you're looking at these, the blue and the green does not intersect anywhere either. And then same thing here, you don't have all 3 planes intersecting at once. This could be if you end up with like 0 equals 10, where you have everything on the left canceling out and it equals a number. So that would be no solution. So we're going to run into some of these scenarios when we're working with systems of 3 equations. Okay? So we'll start this one together, and we will name it inconsistent or consistent or dependent, okay, when we are done. So think back to how we did these yesterday. We looked at, and we're going to do elimination here just for the sake of time and simplicity. We look at 2 of the big equations to begin with. And if you have a variable that has the same number in front already, it might be easier just to go with that one. But I like to work out in front with the x's when I teach this. Okay? So the top 2, it looks like we're going to multiply the top 1 equation, or the top equation, by a 2. And then I'm going to rewrite that off to the side. Okay, so after we multiply that by a 2, you double check to make sure your numbers are right. That way you don't make mistakes. And then we rewrite the other one out. Okay, and right away here after the first step, we're looking at something where everything kind of cancels. That gets me a 0, that gets me a 0, that gets me a 0. And so we have 0 equals negative 5. So sometimes with these, they can be really simple on the first step. If I'm looking at that and I'm like, that does not make sense, then that would be a no solution scenario. And think back to when we classified these, this would be inconsistent, because there is no point of intersection between all 3 planes. Okay? Sometimes they're quick, sometimes they take a little bit more work. In this scenario, this one was pretty quick. Okay? So this one I want you to try to work through on your own. Remember, if you have to keep going a little bit further, you do 2 big equations at a time, maybe the top 2 and then the bottom 2. and you're looking to cancel out a variable. And then once we get the equation from this, and then the equation from this, then you eliminate those together to get your final answer. Okay? So go ahead, pause the video, have everybody work through this one for a few minutes, and then come back and we'll see what we got for an answer. All right, so this one's not too bad since it's just all x's in front. We can just take the top two equations and let's maybe multiply this one by a -1 and rewrite the stuff off to the right. So we got x minus y plus z equals 1. That's my top equation. Next equation down, multiplying by that -1. Okay, so that'll cancel out. We get a -3y plus 2z equals 0. And now, since we got a 0 there, that doesn't necessarily mean we're done, right? If not everything canceled out, then we got to keep going. So that would be my first equation. And now let's do the bottom two. Okay, if you did the top and the bottom, that's fine. I'm just going to kind of do the top two and bottom two, try to keep it consistent here. And we'll take that bottom one again times the -1. So we have x plus 2y minus z equals 1. And then our bottom one, -x plus 4y minus 3z equals -1. And let's finish this one. So 6y minus 4z equals 0. Okay? Now we have this equation and then this equation. And we have to eliminate between those two equations. So it looks like if we're looking in front here and here, we can just take this one times a 2. Okay? And then let's rewrite that out. So that is when we multiply it by 2. And then if we're looking at the other one, we have those two equations. And it looks like the y's and z's will cancel out. So here is your scenario where you have a 0 equals 0. And remember, when you got that, that means it is infinite solutions. Okay, because this does make sense. 0 does equal 0. And this would be called a dependent system, because they're exactly the same plane, or 3 planes. Okay? So let's try one more of these to see what we get. So pause the video for a few minutes and have the students work through this one, and then come back to the video and we'll work together. Okay, so again, I am going to try to keep in front and do the top two and then the bottom two, just for the sake of consistency again. So we will take the top one times a 2 and make that one a negative. Middle one times a 3, we're looking to get a 6 in front. Okay? So -6x minus 4y minus 2z equals -8. That's the top equation. I'll do my next equation. I'll just keep it black ink. So 6 ink, or 6. So next equation, 6x minus 9y plus 6z equals -21. All right, so now we got to just simplify these two out. X's will cancel like we want. -13y plus 4z equals -29. This one could be ugly because we got a 13 in front and a 29 in the back. All right, so now let's do our next two equations. Let's say the middle and bottom. And we're going to take the bottom one by a -2, so that way we can cancel out the x's. So top one there, we didn't change anything. Bottom one, we have -2x minus 8y plus 2z equals -20. And let's add those together. Okay, so we have a -11y, and then a 4z, and then a -27. And this won't be that bad. Okay, if you're looking to do the 11 and the 13, then you're going to have to multiply this one by 13, this one by 11. But that is the more difficult way to do it, in my opinion, because we have 4's in front of the z's already. So let's just use those. Let's take this one times a -1, and then we'll leave this one here. Okay, so negative 13y plus 4z. I'm just rewriting this one out. And then this one we're going to multiply by negative 1. So 11y minus 4z equals 27, positive 27. Okay, z's will cancel. We get negative 2y on the left between the 13 and 11, and then we get a negative 2 on the right. And it looks like this one's going to work out nice. So divide by 2, you get y equals negative 1. All right, now we work back. Take that and let's just plug it into this one since we're close to that one. So that'll make it a positive 13 plus 4z equals negative 29. Simplify here, so move the 13 to the left. All right. So we got 4z equals, that's a 13, negative 32. Z equals negative 8. Okay, I'll circle these while we're going. And then let's take it and plug it into this bottom one. Okay, doesn't matter which one we plug it into, as long as you do both variables in one equation. So this one, there's nothing in front of the x, so I think that'll be easiest. All right, so down here. X plus, so 4 times negative 1, let's change that to a negative 4 since we plugged in that negative 1. And then z is a negative 8, so I'll make it a positive 8 equals 10. So we have x plus 4 equals 10, so x equals 6. All right, so it looks like we got 3 answers that worked out nice, and just write our final answer. 6, negative 1, and negative 8. That is our solution to this system of 3 equations. So it's neither, it's not an infinite or a no solution here. This one worked out. So good practice for that. Okay, so there is your assignment. You will have that on a worksheet. Okay, so please work through those questions. If you get done with that, then you can work on something else. Thanks for watching and have a good day.